Good morning everybody. We're going to take a look today at how SolidWorks can be very helpful for industrial design. So we'll switch over to SolidWorks and we'll take a look. The first thing I'm going to do is I'm just going to open a component or an assembly that has been finished, let's say, by the mechanical department. So you'll see on the screen here that we've got the mechanical elements of a carving knife here. And just while we're in here, SolidWorks is really good for mechanical design, as a lot of you will already know. You can see here that we can actually show how the mechanism of this carving knife works just by pulling particular components. And that side of SolidWorks is very well covered in some other webcasts that we've been through before here at Innova. What we're going to do today is we're going to take a look at how SolidWorks can give some really nice benefits to industrial design. So first and foremost, one of the things that industrial designers tend to do is create sort of rendered sketches, if you like. So we'll show one of these in SolidWorks, and you can see here that we've got sort of the profile sketched out of this knife handle. Now what we can do in SolidWorks, which has been done here, is actually insert those sketches into active documents and use them as a basis to produce a 3D model. And that's exactly what we're going to do here. So this particular sketch has been inserted onto the right plane, so we're going to start a new sketch on that right plane, and we'll just take a look at that normal 2 now. And what I'm going to do is I'm going to use a tool called spline here. You'll be familiar with this one, and we're going to just draw out a 3-point spline, sort of mimicking the top profile of this handle, like so. Now splines are great when you want a nice curvy surface, and some of the things that we can do with splines is show things like curvature. So you can see if you've got nice curvature running across the top there, you'll see it's quite hard to see when they're set to yellow like they are on mine, but you can see here that we've got a nice even sort of curvature comb running across the top of that spline. What I also want to do is just link the end of this spline to the origin vertically, and that just means that when I draw out a profile to sweep along that spline, that the two are going to contact each other. That's really all we need to do for the time being. Okay, so we can exit that sketch. The next thing we're going to do on the front plane here is we're going to draw out the profile that we want to sweep along that path. So again, we're just going to start a sketch. And we'll use a 3-point arc here. We'll start there, we'll come down to the bottom here and then just draw that out like so. I'm just going to ensure that all these points are level, so I'm just going to control select these in the origin and make those vertical. And then we'll just take a look at how far down this arc is going. I really want to make sure that it intersects with the sort of implied intersection of that area there. So we'll just get it so that we can grab a point here. We'll just move that down a little bit like so. You can use dimensions here if you want to, but we're just going to work in a more fluid way. We're going to use the sketch as our sort of guide for dimensioning, so we won't need to add too many numbers to our sketches. So we've now got the prerequisites to create a sweep. So we'll go ahead into the surface section of SolidWorks. And you can see we've got a number of tools that we can use. We'll be using a few of these as we go along. So the first one we're going to use is swept surface. So within a sweep we need to define a profile and a path. We've got both of those. So this is our profile and we want to sweep it along that path like so. And you can see that that does a decent job there, but I'd really like to get the end of this to match the same as the start. So underneath the options here, you'll see there's a lot of options that we've got within here, but I want to keep the normal constant, and that will maintain the arc across the spline path that we've defined. You can also apply guide curves in here and start and end tangencies if you want to. We'll cross those subjects in a moment. Okay, so we've added our first sweep, and you can see that looks pretty good. We may need to refine this end profile a little bit just to sort of encompass that sketch there. So if you do want to do that, you can go back into any of these sketches at any point, edit them, drag it down a little bit, and you'll see that the yellow line indicating where the actual sweep is at the moment will sort of allow us to visualize where that's going to be. So we'll start that now, and you can see that we've captured that a little bit more. Now what we really want to do with this sweep is we want to modify this surface and make it so that it sort of carries this belly shape along the knife handle as much as we can do. And to do that we can use a tool called Freeform in SolidWorks. It's quite a nice fluid tool, very much like what you would find in NURBS modelers like Rhino and Alias. We can start this tool. All we need to do is define a face that we want to adjust. You can adjust the transparency here so we can see through it a little bit easier. And then we just need to set a couple of options here. We want the orientation to be related to the surface, and we're just going to change some of the continuity at the ends of this surface as well. So what that means is we just need to tell the system what we want to happen at these junctions. So at the top here, we're sort of working directly down a line of symmetry at the moment for this component, so we really want to maintain a curvature across that edge. Over on the left and the right hand side we can make these movable because they can adjust if we need them to. And towards the bottom, again, we want to really maintain curvature or at least tangency, but we want to move that edge, so the option we've got there is movable tangent, so we'll add that one there. So the next thing that we can do is we can either add control curves or control points. I want to add some control points, and I want one here to define that sort of push in of the belly, and I want another two around here so that we can pull the base of that curve out. Once you've defined the points, you can actually grab those collectively using the control key and start to pull and manipulate the shape of this down. So you can see here that I can start to pull the whole surface down to match up with the line that we've got at the bottom that we're using as our guide. We can even adjust the sort of influence of the end point as well, that's put in there by default, and we'll just use this point here just to pull it back up a little bit at that end, like so. And you know, you can fiddle around with this sort of shape a little bit more than I have at the moment, adding some more control points and defining it a little bit better, but that gives you a good idea of what can be achieved very, very quickly. Okay, so once we've got that drawn out like so, one of the other things that I want to do is sort of introduce the top sketch which has been inserted into this component. And if we take a look in a top view, you'll see that our surface is currently where this blue edge is, but really needs to be out here. So we need to do a little bit more work in terms of manipulating that surface out to match where the industrial designer's sketch is currently shown. So to do that, what we can do is add in some control curves. And I'm going to add one in directly in the center here, and then we'll use that to manipulate the surface to pull it out. So if I click the add curves button, I can add one there, like so. Just hit escape and that'll come out of that. And then if I select that control curve, what you'll see is I get the same control points that I'd added onto the original edge at the bottom. So again, I can control select these 2 points and start to manipulate this surface in terms of moving it out and refining its position. So again, we'll just sort of tweak this end point here a little bit, like so. We're going to leave this front edge pretty much as it is. We'll just pull it back slightly there just to influence this sort of curve here, but we're going to retrospectively trim that section off in a little while as well, so we'll leave that as it is. Okay, so we've now sort of defined quite a nice surface, but if we want to interrogate this for curvature, we can actually turn on the curvature combs on the entire surface. And you'll see, those of you who deal with surfaces a lot, you'll see that we've got quite a large amount of spikes running sort of top and bottom here, which we really need to do something about. So to do something about that, we're going to add a curve in at the top here, like so. And we're going to use that curve and its control points to start to pull those around and see if we can't refine those curvature spikes just a little bit, just to lessen their impact. So you can see as I start to move these around, we start to lose the massive spiking that we get. And we'll follow the same procedure towards the bottom here as well. So if I grab hold of that and then grab hold of these 2 points, I can start to just pull and flesh out this surface a little bit just to try and refine those spikes just as much as I can. With a few more curves and a little bit more time, we could really adjust those for the better, but for the time being they'll serve the purpose that we need them to do. Okay, so once we come out of the Freeform command, you can see that we now get a really nice surface on the screen that looks really good. Okay, so the next thing we want to do is we want to cut off this front section here just to try and again mimic the sketch that we're copying. So we can do that by creating a sketch. We'll just come into a top view here and start a sketch on the top plane, and we can draw out just a single line here and then cut back across the component like so. And we'll just add a couple of dimensions to this just to control it. So we want an 18-degree angle, and this wants to be 20 mil, like so. And this sketch really is just going to form a trimming boundary for us. Okay, so SolidWorks is very versatile in terms of how you can trim. You'll see that as we go through. Back on the Surfaces toolbar, we can use the Trim Surface tool here, and we can use the sketch to trim. And then we've got a couple of options here. We can either choose to select what we want to keep or what we want to remove. And you'll see that the sketch actually creates a defined boundary on that surface for us. So we'll cut that section away, and that's going to form a nice straight portion on the front of that knife handle for us. Before we mirror this over to the other side, we really need to fill this surface in. So I'm going to use a tool called Filled Surface here, and we're going to select a boundary like so. At the moment it's not going to close that up. A lot of systems sort of dictate that you would need to define a boundary between these 2 points here, but within the Filled Surface tool we can actually toggle on the option to fix up the boundary, and it's going to create that boundary for us, which is quite nice. So if we click the green tick there, we end up with our sort of flat surface on that end. Okay, the next stage for us is to mirror those 2 surfaces over to the other side, and we'll just check the integrity of the surfaces that we've created. So on the standard features toolbar here you'll see mirror, and we just want to select the central plane here, and we want to select some bodies to mirror, which are these 2, like so, and we can mirror those onto the other side. Now once we've mirrored them, we may want to knit them together. So in SolidWorks we end up with separate surface bodies unless we knit them together. So there's a tool for us to do that within the Surfaces toolbar. Just at the top here we can select entities to knit together, like so. And you'll see that it will show us if there are any gaps between the surfaces and the size of those. We can see we've got some really small gaps here, and I can just toggle on to allow the system to actually knit those gaps together, and we end up with a combined surface body now. So what I'm going to do, I'm just going to hide the 2 sketches, and then we're going to turn on something in the display options called zebra stripes, and that will allow us to interrogate the surface in a little bit more detail. So these zebra stripes just allow us to look at where surfaces cross each other. So right at the top where we've mirrored these surfaces, you can see that the zebra stripes are exactly in line. That has occurred because of the curvature constraint we added to this top edge when we modified the surface. So ideally on consumer products, things that people are going to look at, or highly reflective surfaces, you want to maintain a good level of curvature across any sort of joins like we have here. And you can see that because the zebra stripes line up exactly, that indicates that we have a good match of curvature between the 2 halves. Anywhere where you get discrepancies or big changes in curvature, you would see something like what we have here between these 2 surfaces. So we've got a very large zebra stripe and a very small one this side, and they don't line up exactly. If we take a look at the bottom as well, we should see that we've got a nice crossover at that intersection as well. So that looks really good. Okay, so we can turn off those zebra stripes. We don't need those anymore. Okay, so we're getting somewhere with our sort of product here. I'm just going to bring back the right sketch, because the next thing we need to do is we need to put on this back end to the handle here. You'll see that maybe we've come a little bit longer with our sort of swept profile than we may have wanted to. what we can do there is we could drag a reference plane maybe to about there. We'll just define that a little bit more specifically with a size, so 175, and we can actually use that plane to trim the surface as well, so we could remove that back portion if we wanted to, just to give us a little bit more area to work with to create this back section. Alternatively, we could have gone back in and modified the original sketches if we wanted to, but it's quite a nice quick process, and it shows you another way that we can trim in SolidWorks. So we need to create this end here. I've actually got a sketch defined already for the base of the sort of foot. And really what we're doing here is we're creating a section so this carving knife handle can stand straight up and not roll around a work surface, so we just need a flat foot for that to fit onto. So we're going to introduce another tool here called Boundary Surface. This is a really flexible tool that can be used for a lot of different situations. It's quite nice here. So what we're going to do is define some directions, so some profiles for the directions. We can use a tool in SolidWorks called the Selection Manager. This will allow us to select groups of entities, open loops or closed loops. We're going to use it for a closed loop here and select these two edges of this surface at the back. So you'll see here using the closed group tool within the Selection Manager, it allows me to select that as one entity. I can just accept that and then choose the next profile that I want to create the boundary surface between. And you'll see we get a very straight transition between the two. Now that would be fine in some situations, but what we want to do is try and maintain a level of curvature between this surface. So what I can do is select the first closed loop here and then define an end condition on that. So here we're going to maintain curvature to face, like so. And you'll see that that matches quite nicely up with the curvature defined in the original sketch. Now what we can do is manipulate that with a numerical value here, or alternatively we can drag and pull that out and manipulate it a little bit more. So maybe we just want to match slightly more than we were originally, and you'll see that we get the curvature cones up on there as well, which is really nice. So once you're happy with that, you can click the green tick and you'll see that we get a nice sort of sweeping handle shape like so. So we can hide our sketch again, we don't need that necessarily. So the next thing we may need to do is close off the base of that, and we can do that using the Filled Surface tool. We've seen this tool already, so we can just select the two ends there and close that off, and it creates a flat surface for us. Okay, so now that's done, we just need to sort of knit this portion to the main surface body, so we can use our Knit Surface tool again, select those two and the original one, just heal any gaps, and we can join that together quite nicely. Knitting that together just allows us to fillet this particular edge here, so we could say we want a constant radius fillet of 2 millimeters, for example, and we can do it around that entire bottom portion like so, and we end up with our nice sort of flat foot there. Now taking a look towards the front of this handle, there's no sort of finger guard for the blade in this design at the moment, and that is something that we are using from an external supplier. The external supplier themselves use Rhino as a product to design their components, and they've sent through a file in Rhino format. Now one of the things that's good about SolidWorks is its sort of data import from other systems. So if I just open the open dialog here, you'll see a range of file formats that we can open, and one of those is Rhino. So if we select the Rhino format, we can see we've got a Rhino file here. 3DM is the native extension of those files. So we can select open, and it will convert that file into a SolidWorks file. It asks me if I want to run import diagnostics, which I don't, so I can just say no. And you can see here that we've got our Rhino file imported. It actually comes in as a surface body, but we really only need to show it in our file, so that's fine for what we're going to do. So we can save that as a SolidWorks file now, and we'll just save it over the top of what we've got. and then we'll just move back to our assembly here. Now what we're going to do is we're going to insert that guard into our assembly, so we can just select that component. You'll see we can place it anywhere on the screen, but I've sort of configured this so the origin snaps it into position, so we're going to click OK, and you'll see now that we have that guard in position. Now one of the sort of requirements that we have from a design perspective is to maintain the curvature that this guard has at the front of our knife handle, and at the moment we don't have that. We have a sort of flat front, so we need to do something about that. So I'm just going to edit this component again and start a sketch in the right plane. What we can do, which is really nice in SolidWorks, is take data from other things and reuse it. So here I'm just going to select this edge. I'm going to toggle on the option to create no external references, and all this means is that I'm basically going to copy this edge into my active part, and I don't want it to create a relationship to this component, because this component can move forwards and backwards with the knife handles. We don't want the front of our knife guard moving front to back. So if we just toggle that option on, we can convert that, and it gives me a little warning here, and it's going to say the references will be broken, which is fine. We're just going to select that, turn it into construction geometry and fix its position, and that's fine. And then we're going to offset a line from that in the reverse direction. We're not going to add any dimensions, and we're just going to say OK. What that allows me to do now is maintain the curvature of that arc whilst being able to manipulate its size. So you'll see I can move it front to back, round to wherever I want it, and I'll roughly get it into position there, and that's fine for how we want to sort of sculpt the front of this this handle. So what I want to do is create a two-directional surface for the front of this handle. So I need to create the other direction curvature. So I'm going to do that on the top plane, and we'll just put ourselves into a top view here, and I'm going to use another 3-point arc like so. We'll just ensure that the center point is aligned with, we'll just ensure the center line is aligned vertically with the center of our component, and then we'll just add a relationship between those two endpoints to make those in line as well. And again, we could sort of add dimension to this arc, but we're going to leave it as it is. I'm just going to add a point onto this here, onto the center of that arc, and then I can use that point to create what's called a pierce relationship between the two curves, like so. And all that ensures is that the two curves contact each other, and I can now start to manipulate the size of that curve around if I need to, which is quite nice. Okay, so once we're happy with the sort of general position of those two curves, we can exit the sketches, and we can use the boundary surface tool again here to create that two-directional curve. So what's slightly different to what we did before here is we're going to select two directions. So the first direction is going to be this line, and the second direction is going to be this line here. And you'll see we get that nice curved surface on the front of our handle. So I'm quite happy with that. You can see the curvature cones on here as well, just to give you an indication as to what the curvature is like. So we'll just click the green tick to accept that. And then what we can do here is again use trim surface. We'll toggle on the option to use a mutual trim here, and that allows us to select two surface bodies and then use those as the trimming boundary. So I can select the items that I want to remove, and we've now got the nice sculpted front that matches our guard on the front of our knife handle. Okay, so that's got us quite a fair way through that, but there's just a couple of other bits that we want to do first as well. I'm just going to hide this surface body and just show the sketch again here. So if we just take a look at the right sketch, you'll see there's a section of the design that's cut out for the operation button. We just need to recreate that. So we'll just bring our surface back, and I've actually got a defined sketch for that, which we're going to use to trim our design. So if I just pre-select the sketch and the trim surface tool, we need to go back onto standard trim and just select our sketch again. I can then specify that I want to remove that section from our design like so. Now we need to fill this in with some kind of surface, so we're going to use filled surface again, and we can select the two edges that form the boundary, and what you'll see is it skins quite a nice surface across the top there that's pretty flat, so that's fine. We'll just click the green tick and we end up with that surface. We'll just use our nit just to position those together and accept that, and we're pretty much done in terms of what we want to do on here now. But before we move on to the next stage, which is to create a solid item out of this, we really need to fillet some areas of our design just to make it a little bit smoother. So we're going to use our fillet tool again. I'm going to specify an 8mm fillet to run at the top here and at the bottom here, and you'll see it pre-selects the mirrored edges of those as well. So we've created a nice rounded section to the front of that handle. Now I want less of a sort of sharp difference between these two surfaces, so I want to fillet this area. So if you click enter, it'll repeat the last command, and I want to fillet give or take around 3mm, just running around this edge here. And one of the things you'll notice when you do fillets is that sometimes we can get this sort of tapering in of a fillet when you have different angles of surfaces coming together, and that's not something that I really want in this design. So what I can do is I can use the face fillet option within SolidWorks, and that allows me to select this face and this face here. It will pick up all the faces around as well for us automatically, and you'll see there's no difference in terms of the fillet at the moment. But one thing the face fillet gives you over a constant radius is we get some more options, and we can toggle on the option to maintain a constant width fillet. And what SolidWorks will do is it will work out all the sections around that area where the fillet is changing and modify the radius to suit our constant width. So if we click the green tick there, we get our nice constant width fillet running around there. And we'll just do the same over on the other side. So face fillet, select one face and then the second face, and just toggle on the constant width option there. And we end up with our very nice looking handle. Okay, so we're pretty much finished with the sort of sculptural design element of this handle. Now we really want to turn this into a solid item. So we can use a tool called Thickening in SolidWorks. At the moment this is a surface body, so just before we do thicken, if we just take a section through this, you'll see the surface itself has no thickness. Compare that against a solid item like the blades and you'll see there is a thickness there. So we need to give this a thickness, so the thicken tool is used for that, and we just need to define a wall thickness here, so that's going to be 2mm, and you can also predefine a direction to thicken it in. So side 2 typically is inside, side 1 is outside, and this one is mid-plane. So we're going to select our surface and then that's going to thicken internally, and we'll just check that by using our section tool here and picking a particular direction. And you can see now that we've got a thickness all the way around our handle. So one of the things this section tool is very good for is sort of visually checking for interferences. So you can see here that we've got a good clearance around that motor element and the mechanism at the front end of that knife handle. So that's quite good. If we want to be a little bit more specific with our interference detection, we can use some tools within SolidWorks to do that. So under the Evaluate toolbar, we've got interference detection. We can just calculate any interferences within here, and you'll see that we end up with 2 interferences that are highlighted in red. And you can see that's where the blade actually comes through the front end of that handle. We haven't done anything for that. So a good check just to confirm there are no interferences in the main body of it. So we've done a good job with shaping the body of our handle there. But we do need to rectify these little issues here. So now they've been pointed out to us, we can come out of the interference detection tool and we can edit the part and just do something about that. So a nice tool that we have in SolidWorks is called Indent. That allows us to create a cut using other geometry, so other parts, things like that. So this is our target body, and we want to use these 2 blades here to cut the front of our knife handle. And we can specify an offset size within here, so maybe we put a 0.5 offset around those just to give it a little bit of clearance. Just click the OK button and you'll see there that we create those two cutouts just to allow those blades to move. Okay, so that's worked really well. So we're sort of done now in terms of error checking. So we're going to open this part in its own window and just check a couple of other things just before we move on to the next stage. So once you've done a design like this, one of the things maybe worth doing is using a draft analysis tool. Here we have one in SolidWorks to do that. So all you need to do is specify a direction that the pull's going to go in and an angle that your recommended minimum for the draft angle. And you can see that we've done a pretty good job here in terms of making sure the surfaces are all drafted so this can pull out of the mould. So we've got a good split line running across that component as well. So a good visual check here, and it will show you the draft angles as you move around, which is quite nice as well. So if you leave that draft tool on, it will display. So if you do need to make any modifications, you can keep that colour up if you want to, but we're okay. So what we're going to do now is we're going to split this component. So to do something like that, we can use a tool in SolidWorks called Split, which we have here. So if we start the tool, we can select a plane to cut the part and then just click Cut Part. That could be a sketch if you wanted it to. And it's going to show us the two bodies that we've created in that component. So I can toggle on those two bodies to keep, and it's going to define the names of those bodies for me, and we end up with two halves of our component, like so. Two halves of our solid component. Now, because this is a moulded part, we may want some kind of jointing detail between these two items to allow them to be fitted together easily. And a really nice tool within SolidWorks is called Lip and Groove. So we're going to use the Lip and Groove tool here. All we need to do is select a body that we want the lip or the groove to be on. So the first one is the groove, and we'll select the second body for the lip component. So the groove face is going to be the inside face here, and the groove edge is going to be the inside edge of that component, because what we don't want to do is affect too much the external display of this component. So we'll just select these edges here like so, and that will create the lip on that or the groove on that component. The lip selection is pretty much the same, so we just select a face to use and the edges, so we can select the same inside edges. And this tool was brought in a couple of years ago because these type of features typically used to take sort of 3 or 4 features to create, which is quite time consuming. They've been conglomerated here into one command. So just towards the bottom here, we've got some controls over how that lip and groove, in terms of its sizes, that kind of thing, draft angles, bits and pieces like that. We're going to leave those as they are, and SolidWorks will do the rest for us. So we just get a small message about some drafting problems which we could rectify manually, but we'll just use the section tool here just to have a look and see what the lip and groove tool has done. And if we take a look, you can see that it's actually done a really good job there of making those two halves for us. Okay, so we're going to move on to the next stage. I'm just going to hide both of these bodies here and just bring back the original sketch so we can take a look. And you can see that the industrial designer sort of indicated an overmoulding, a sort of type of rubber section on the component for grip. So we're going to go ahead and recreate that now. So if we bring back our solid bodies here, just bring those two back, and we'll just bring our original sketch back as well. We'll take a look in a right view here, and we'll just create a sketch on the right plane as well. We'll just hide one of these bodies out of the way just so we can see the original sketch. And then I'm just going to use a 2-point spline here, just defined at the 2 end points. And the nice thing about 2-point splines is we get manipulation handles at either end, so we can start to pull and manipulate that spline around. So it works quite nicely in that situation there. And it will also work really well for us here as well. So if we just create our spline at those 2 points, we can actually pull and manipulate that around to match the contours of that sketch. Maybe if we just use this handle here, we'll just pull that around a little bit, and we can start to create that sort of shape. Now over on the back here we had some new functionality introduced in this release of SolidWorks, which allows us to create conics. So we can actually use the conic functionality here just to create a nice shape there as well. These conics are really controllable. You can actually control them with row values if you want to, and manipulate them afterwards like so. But that'll do just to sort of showcase what we've got there like so. So we've created that sketch. All I need to do now is just create a surface that I want to trim. So I'm going to select this face here. I'm going to use the offset surface tool and offset that by 1mm like so. And then what we're going to do is we're going to use trim surface again with our standard trim and that sketch line, and we're going to select to keep this middle section like so. So if we keep that middle section, we can then thicken this internally by 1mm like so, and we'll just toggle off the option to merge the results, and we end up with our sort of overmolding section. Just going to use the fillet tool here, and we'll just use a 1mm fillet just to round off some of these edges. And within this fillet tool you actually get what's called a smart selection. So here this is going to grab all the corners for me without me having to pick those, and we can just add that on like so. And maybe we just put a sort of 0.25 fillet running around this top edge as well. So we'll just let that figure itself out, and it establishes it can't do it that big, so we'll just make a change there to 0.25 and add that fillet all the way around the outside there. And then maybe what we need to do here, because we want this on both sides, is we'll just use the mirror tool again on the right plane and select that body and mirror it about to the other side, and we end up with our two halves of our moulding over the top. Okay, so if we just switch back to our assembly, we've got a couple of other things we can do at this point as well. We're sort of finished on the design side, but in terms of visualization, SolidWorks is really good at visualizing what the product is going to look like. We can go into the right hand side here. I'm just going to pin this down. We can take a look at the appearances that we can apply in SolidWorks. So maybe we drag a matte rubber onto this item and onto the other side here, because they're two separate bodies. And maybe we want a particular plastic colour just shown on this item, so we'll use a medium gloss plastic, let's say yellow, and we can drag and drop that onto the component as a whole, and we can get an idea of what that looks like. In SolidWorks you've got something called Real View, which sort of adds a more realistic reflective appearance to items like so. And one of the other nice things that we can do is actually define cameras within SolidWorks as well. So here I'm just going to define a camera. On the left hand side you control where you're looking at, so maybe we want to just zoom in a little bit and focus on the handle a little bit more than anything else. You can use this little red dot to sort of focus in on particular areas, and we can define a camera like so and then view that camera, and we've got our nice defined view of what we're looking at set up in SolidWorks. Once we've defined appearances, we can also place the object in scenes, and SolidWorks comes with a number of default scenes. These really define the sort of lighting environment that you're working in. So you'll see as we toggle through some of these that the lighting will change, the reflective nature of the material sort of has different high and low spots on it. So we can start to see in which environment our object looks very good, as a nice way just to sort of show this to, you know, people that you want to demonstrate the product to before actually making it. So once you're happy with a scene, you can adjust all aspects of this scene within the property manager on the left hand side. So we can start to adjust whether or not we have floor reflections, how high the floor is, in which rotation the environment's in, which can affect the reflectivity, and bits and pieces like that. You can also adjust the influence of the lights in here as well. But once you're happy with how the product looks, we can use a particular add-in called PhotoView 360, which is one of the add-ins we have in SolidWorks Professional, which will allow us to create a rendered image of this item. So the first thing normally that you would do is open a preview window and get an idea of whether or not the appearances you've defined make the product look okay, so whether you've chosen the right kind of rubber, that kind of thing. And if you hover your mouse over certain areas, it will focus in on rendering that area first. So you can see here we're starting to move over the rubber and it's refining those areas. Once you're happy with the preview window, you can then go to the options page and specify sort of pixels, sizes of your images. I'm just going to do mine at 800 by 600 just to allow this to run very quickly. Once you've set all that options up, you can then go to the final render and we can take a look at the final render screen. So depending on the number of cores your computer has, depends on the number of orange squares you'll get on the screen, but you'll see they can process images quite quickly to quite a high level of realism. You know, I've spent literally next to no time on that image just to give you an idea of what can be done. Okay, so once you've presented the product to somebody, you know, maybe it's the owners of the company or the client, and they're really happy with what you've done, you may want to just check your design for its manufacturability. So the next thing we're going to do is take a look at a product in SolidWorks called SolidWorks Plastics. So what we're going to do is we're just going to save out one of these bodies in this particular component. So we're going to save out one half of this moulding just to try and get an idea of whether or not it is mouldable. So we'll just give that a name and we'll save that, and then we're going to take a look at whether or not we can mould this. So again, another add-in that we have available for SolidWorks is SolidWorks Plastics. So we'll turn that on and it will load a different section to the software. This allows us to understand whether or not the product can be moulded. So the first thing we need to do in SolidWorks Plastics is give the component a mesh to allow the study to run. And there's two types of meshes in SolidWorks Plastics. The first one is a solid mesh, which will mesh the void and every external face. Now these types of meshes can take a little bit longer to generate, but are more accurate in terms of their results. The second option we've got is a shell mesh. These are a lot quicker and they will mesh every external face and every internal face and then leave the void of the product as a void. So these can be a lot faster to run, more efficient for your system to generate, but the results are a little less accurate. So we're going to use the automatic settings for the shell mesh. So all we need to do is right click on that shell mesh and say auto, and then it's going to calculate and work out what it thinks the best size mesh is. So those of you who are familiar with simulation tools will know that the meshing can take a little while depending on the refinement level, and if we went into the manual settings and defined those, we could refine the mesh a lot further. So the next thing we need to do is choose a material. So we're just going to open the database that SolidWorks Plastics has, and this contains around 4,000 materials. Now we can sort either by family, so in terms of plastic family, or by the company that produces the material, so Dow Chemicals, BASF, typical ones in there are those kind of things. We're going to choose the generic grade of ABS, but if you have a look through this list, you'll see there's a load of your sort of familiar materials that people will use for plastic components. These contain all the temperature readings for the plastics, the viscosity at certain temperatures, and they just allow us to create an accurate mould flow of what's going on. So once you've chosen your material, you can just click OK, and the next thing we need to do is define how the plastic is going to be injected into the component. So it's more a how and where, so we need to define a gate location. So if you just open the gate section, we can just click on an edge and define a gate. So just add that gate on, and then the system is going to use that as the injection point for the plastic. That's really all we need to do in its sort of simplest forms. We can let the system do the rest and start to run the analysis. Okay, so once the study's completed, we get some really nice plots to help us visualise what's actually happening when this component is moulded. The first one is a fill time plot, so it'll allow us to see the flow of plastic through the cavity and understand which bits are going to be moulded last and which ones first. And then the system will calculate things like weld lines, so where the flow of molten plastic moves past an obstacle and rejoins, we get weld lines created, and these can sometimes impact the strength of the component, so it's quite important as a designer to understand where those are possibly going to be. Along a similar line, we also get indications of where air traps occur, so because we're forcing molten plastic into a cavity that contains air, we're effectively compressing that air down into a very small area. And if we keep compressing that without venting the mould, we can cause explosions, which will, can sort of blacken the plastic at that point and cause sort of, cosmetic degradation. So again, it's important to understand those where those are as a designer. We're quite lucky in this instance because the air trap is created right on where the split line of the mould is, so it gets some natural venting, so to speak. You can see also we'll get an idea of the cycle time, so the fill time for this particular component. We'll also be able to see cooling time and quite a large amount of other plots that we can review. There are some specific webinars on this product as a whole, so it would be worth looking at those if you're interested in this side of things, but a very useful product nonetheless. Okay, that sort of brings us to the end of our presentation. So if I just come back to our PowerPoint slide here, I just want to say thank you very much for watching. There are some future webinars that we're running listed up there for you at the moment, so if you are interested in those, then please have a look at our website for more details. In terms of costing and sales of SolidWorks, it would be worthwhile you getting a hold of your account manager, who is Andrew Norrie. So I've put his email and his contact details at the bottom there. So if you are interested in pricing or looking at the different packages available, then please get in contact with him. Once again, thanks very much for watching. We'll see you again next time.